voltage that is also in the 12 voltage that was in the 12 voltage. Okay, right? Any questions? Did you follow me? The tail is fine. It's good. Okay, it's good. White is fine. All right. Here's one is good. Yeah. So now the 12 voltage means it's right there. V sub R sub 1 plus V sub D sub 1. I sub R sub 1 multiply R sub 1 plus V sub D sub 1 silicon is 0.7 volt. Will you follow with me? If you have any questions, please let me know, okay? This is the last chance to in here. So now the I sub R sub 1 multiply R sub 1 was the given. I think you can see in my lecture printout, this is the 2 kilo ohm, and R sub 2, 3 kilo ohm here, and R sub 3, 1.5 kilo ohm. So R sub 1 is the 2 kilo ohm plus 0.7 volt, okay? All right? So now, in here, what is the I sub R sub 1? So that was the 12 voltage right there. So the 12 volt minus 0.7 voltage divided 2K, that was I sub R sub 1. So I'm going to be using the calculator right now. The 12 minus 0.7 divided 2000, that was 5.65 million. Okay, 5.65 million. This is the one of the answer for these questions. So I might be making questions for first exam, one circuit, and the question one, what is I sub R sub 1? What is the V sub R sub 1? You know, something like this. One circuit, several questions, okay? Maybe four, maybe not five, 3 or 4, the big circuit, and I can ask you a lot of questions. And 4 and 5 are some definition questions, okay? And 2, here, it's right there, here, second one here. So V sub D sub 2 plus V sub R sub 2 is what? The 12 voltage. Now, the V sub D sub 2, silicon, 0.7 volt, I sub R sub 2 times R sub 2, 12 volt. And R sub 2 is what? 3 the K ohm. So now, the I sub R sub 2, 12 volt minus 0.7 voltage, the divided 3K. So 3K to 3000. So now I'm going to using the calculator one more time. That was 3K was, okay, 3.76 milliamp. Don't confusing the unit, okay? Don't confusing the unit. That's right there. So the I sub R sub 2 right there, here. And then, okay, right there. The 3 is V sub R sub 3. That's right there. I'm writing maybe another color right there. So the V sub R sub 3, could you see that? It's fine? Okay. V sub R sub 3 is I sub R sub 3 multiply R sub 3. R sub 3 is, it was given from the circuit, 1.5 kilo ohm. Okay, 1.5 kilo ohm. That was V sub R sub 3. What is the V sub R sub 3? Same as supply voltage, because are in parallel between any components right there. No components here. That should be the same. So here, that should be, let's say, the 12 volt. So I sub R sub 3 is the 12, and what divided the R sub 3, 1.K. That was the calculated 1.5 times 10 to 3. So now that was 8 the million. So the answer is the 8 the million. So now go back to the circuit here. Here, okay. Let's say I'm gonna write more the greenhouse. That was the total current here, and then that was the I sub R sub 1. This is I sub R sub 2. That was the I sub R sub 3. That was the junctions. Okay, that was the junction. Okay, so in here we can define I sub t is equal to I sub R sub 1 plus I sub R sub 2 plus I sub R sub 3. Okay, this is also the I sub t. Okay, it's right there. All right, any questions so far? So now in here we can find the I sub t. Oops. So in here so the I sub t, I sub R sub 1 plus I sub R sub 2 plus I sub R sub 3. That was 3.76 million for I sub R sub 3, and 5.65 here, 5.65 million, and then the I sub. Oh, I'm sorry. That was the five. I'm sorry. This is the 5.65 million plus the I sub R sub 2 here, 3.76 million. So now, oh, I'm sorry. Maybe I sub R sub 3. That was the 8 million, because right there. Okay. So this is the altogether was 5.65 plus 3.76 plus the 8 was the 17.41 million. Okay. All right. The fifth one is what is for the total register. So you don't need to do the calculators like maybe all things. Just the total register is what? E divided the IT by using the Ohm's law. Okay, the Ohm's law. That was E. From the circuit, we can get the clue of the voltage is the 12 voltage. So 12 voltage divided 17.41 milliamp. So the after calculation, 12 divided 17.41, it was 0.689 kilo ohm. Why? Because 1 milliamp, 1 milli is 1 to 10 minus 3. That was the 10 to 3. Okay, it's right there. So this is why here. So that was the kilo. Okay. All right. Any questions? Okay. Okay. So the second question is for. Okay. Now the Y. What is the V sub R sub 1? That was. Do you remember? 3 plus 2 times 10 volt, and V sub R sub 2 is 2 plus 3 over 3 times 2, 6 voltage, 4 voltage. So now in here, the voltage drop 4 voltage. In but V sub R sub 2 is 6 voltage. Why? Because the KVL rule, E is the 10 voltage, is V sub R sub 1 plus V sub R sub 2 should be the same, right? But the KCL, in the series circuit, I sub R sub 1, I sub R sub 2, and I sub T. What is the I sub T? That was the total current. This is the I sub R sub 1. This is the I sub R sub 2. Series the same. But, yes, why? But I wanted to, okay, just the I wanted to adding to, for example, like this one. Or, right, this one here. This is the, for example, R sub 2, R sub 3, R sub 1, R sub 2, R sub 3. Now, maybe in here, for example, E is V sub R sub 2 and what? And V sub R sub 3. I'm going to just keep reminding of you. Okay, this is very important. Here, E, right? Right? So that was the I sub T is what? The I sub R sub 1 plus, I'm sorry, this is the I sub R sub 2. This is the I sub R sub 3. Okay? So I sub T here, the Y, maybe I sub R sub 2 plus I sub R sub 3. Will you follow with me just right here? Yeah, but here, E is the V sub R sub 1 voltage drop, okay, here. The V sub R sub 1 plus V sub R sub 2, or V sub R sub 1 plus V sub R sub 3. Hey, professor, what does that mean? Here. In series, this is the junctions. The before junction, any register, that should be the same current. Hey, professor, what does that mean, the junction? The two more line to connect. Here. That is this is junctions. Hey, professor, this is a junction? No. 3 lines should be connected. 1 junctions and 1 junction. No junction, no junction, no junctions. This is a junction. That is a junction. That is a not junction. The junction, at least 3 more line connect here. So in the here, the I sub T, the I sub R sub 1, and I sub R sub 2, and I sub R sub 3. Same thing, the I sub T. So I sub T is I sub R sub 1. Why? Because that was not the junctions before. So I sub R sub 1 is what? I sub 2 plus I sub R sub 3. Run it more. Okay? It's fine. All right. Any questions? All right. So maybe again, the analog device 1 until chapter 4 is really like to the DC circuit. So if you really feel like it's really not familiar with or need to study more, you have to invest your time more for the review for the DC circuit, okay? But after chapter 5, they require the AC circuit. So that is what you need to do. All right. So now I'm gonna keep the working for sample circuit here. Okay. Now, here, that was the question 5. Okay, the question 5. You can see the lecture here. Okay, it's right there. This is the E, 220 volt, and R sub 1, 330 ohm here, and R sub 2 is 220 ohm, and D sub 1, silicon here, And D sub 2 also silicon. So now here we go. What is for the V sub 0? What is the V sub 0? V sub 0 like this one. What is for the V sub 0? V sub 0 is the V sub D sub 1. What is the V sub D sub 1? This is the first diode of the voltage drop here. 0.7. Can you see that? I mean, this is the long bar is the plus and small bar is the minus. So the current like this one, okay? Okay, that was the passing through. But however, see that? It's going through or not? No. Why? It's a reverse. It was the reverse bias. Do you remember here? Here, this is the plus, this is the minus, this is the I sub F. Okay, that was the passing through. It depends on silicon, second approximation, 0.7 volt, and germanium, 0.3 voltage. Hey, professor, what is the 0.7 and 0.3 voltage? So do you remember the PN junctions? Some point and the over voltage, they break through from the P to the N junction to current. Do you remember, right? So that was to the 0.7 and 0.3 voltage is like max voltage to the current through. So, however, maybe in the diode PN junction, that was the reverse. Okay. Forward is current through. That was 0.7 or 0.3, depends on material. However, reverse, no. So go back to the circuit here. No, why? So yeah, you have to write in the region of the reverse. No. So for this case, that was the open circuit, no current. So that was what? V sub D sub 1. So from the circuit, we can make a formula. E is V sub R sub 1 plus V sub R sub 2 plus V sub D sub 1. Okay. And also V sub out is what? The V sub D sub 1. What is the V sub D sub 1? That was the 0.7 voltage. Why? Because that was silicon here. Silicon. Oops, I'm sorry. Silicon here. There we go. Okay. So in the second approximations, okay, in the second approximations, we assume that that was operating as 0.7 voltage, the voltage drop in here. Okay, so now supply voltage. So E is 220 volt is V sub R sub 1 plus V sub R sub 2 plus 0.7 voltage. And then 220 volt minus 0.70 volt, R sub 1, I sub R sub 1. The Ohm's law, okay? And plus R sub 2 times I sub R sub 2. But R sub 1 times I sub R sub 1 is I sub T in the series, in here, white, right? In the series, or passing through each register, same as the total current. So right there, go back to the circuit. R sub 2, I sub T. Now R sub 1 and R sub 2 was given value. That was 303, the 30 ohm plus 220 ohm, the I sub T. Now, the I sub T, 220 voltage minus 0.7 voltage, divided 330 plus 220. So now 219.3 voltage, 550 ohm. Okay, so now I'm gonna using the calculate 219.3 divided 550. That was what? 0.398 m. Don't missing the unit. Okay, and then so that is the answer. The I sub. Okay, all right. Any question? Okay, this is the 0.7. You can draw the circuit from the circuit, and also you have to know why that was not V sub D sub 1, because that was the reverse bias here. The reverse bias that was not the flowing in the diode. Okay, so keep in mind. Just the only voltage drop supply as the work as the supply voltage in the forward bias. Okay, forward current. Okay. Any questions so far? Okay. All right. We have a few more circuit. What time is it? Okay. 1:45. We have the two more circuit. Okay. Now, okay. So the question 6. Okay. The question 6 here. This is the R sub 1. Okay. The 2 kilo ohm. This is the E and 12 voltage. And that was R sub 2, 500 ohm here. And then D sub 1, GE, and D sub 2, GE, the germanium, right there. And then the R sub 3 was 1 kilo ohm here, right there. D sub 3, D sub 4. silicon, and silicon. So the question is, what is V sub R sub 3? Question 2, what is V sub R sub 2? Question 3, what is V sub R sub 1? Question 4, what is I sub T sub 4? Question 5, what is I sub R sub 1? Question 6, I sub R sub 2. Question 7, I sub R sub 3. Okay, but the 5 minutes, just the thinking, okay? Just my thinking. So you have to find what is the each diode. You have to change diode. What kind of battery is for the each 4 different diode? You can calculate it and show me, okay? So I'm gonna give you the 5 minutes. Just I'm gonna try. If you have any questions, please let me know. Okay, Daniel, not in here. But Stacy, right. That is the really similar question for the quiz and then the first exam, okay? Just like this one. Okay. Um, okay. Okay. This is the last. I think we have the one more question, but okay, here we go. So just right there, here, what is the V sub R sub 3? Okay, so now that point A, that point B, that point C, that point D. So A, B, C, D. Right? Right? Right or no? No. Why? Maybe R1? Maybe how about Houston? Yeah. So A, B, D is the same, but the C is not. Why? So Tyler, you understand? No, just to follow you. You got all A, okay? Congratulations. All A. Okay, gotcha. Right. B, A, D is same. Why? It was parallel. What does that mean, Professor Parallel? Nothing here. Okay. But here, C and D, they have something. Any component, register, capacitor, whatever, that should be not the same. That should be not the same. For example, it's for 12 voltage, that was 10 voltage, spike body. Boom. So when you make maybe any circuit, or for the future, my class, or any class, whatever, it's like the microcontroller, my class, something wrong connection is like running. So keep in mind for your robotic as well, okay? Circuit should be the power supply. If you want the same thing, nothing, or in the parallel, okay? Series and the parallel is very important. In the last semester, some student asked me, "Hey, professor, how can you define R in parallel? The junction. What does that mean, junctions? Two more with the three line connection. The junction. So R3, D3, D4 are in parallel. That are in parallel. What? The junction and junction. Okay? That makes sense? Hey, professor, that is a parallel? No. Why? That was not junction. That was not junction. Why? Just on the two line. Two line. Should be the three line. Make a meeting. Okay? I know. So now the V sub R sub 3 is, oops. So the V sub R sub 3 means V sub D sub 3 plus V sub D sub 4 is V sub R sub 2 plus V sub D sub 1 plus V sub D sub 2. Okay? It's very important. Here. Same. Okay? Same. V sub D sub 3 plus V sub D sub 4 is from silicon materials means 0.7 volt plus 0.7 volt, 1.4 volts. So right there, V sub D, 1.4 means V sub I sub 3 is 1.4 voltage. Okay, so the answer is the 1.4 voltage. So maybe any question? Okay. Hey, professor. Yeah. Okay. Hey, professor. What is the V sub R sub 2? It's right there. Plus, minus. So the V sub R sub 2, I sub R sub 2 multiply R sub 2, maybe, or V sub R sub 3 minus V sub D sub 1 minus V sub D sub 2. V sub R sub 3 is what? 1.4 voltage. What is the V sub D sub 1 here? What is the V sub D sub 1? Yes, 0.3. And minus what? God bless. You got an A, okay? If you want, it's good. Amazing. Yeah. The 1.4 minus 0.6 volt is like the 0.8 voltage. Awesome. So the V sub R sub 2, 8 voltage. So now the last one is V sub R sub 1. What is the V sub R sub 1 here? Plus, minus. We have a lot of approach to find the V sub R sub 1. For example, that was I sub R sub 1 times R sub 1. If you know, but we don't know. To find I sub R sub 1, there is a lot of more approach. So in here, so the V sub R sub 1 here is what? E minus V sub B. What is the E? The 12 voltage. What is the V sub B? Same as the V sub A. What is the V sub A? 1.4 voltage. So that was 10.6 voltage. So the V sub R sub 1 is 10.6 voltage. So any question? All right. So now in here, okay, what is for I sub D sub 4 in here? So the I sub D sub 4 is I sub D sub 3. Why? Because the diode are in series. For example, for D sub 4 in here, I sub D sub 3, I sub D sub 4, I sub D sub 5. Sometime in here, for example, in here, D sub 3, D sub 4, the I sub 1 in here, that was I sub D sub 3, I sub D sub 4, and I sub 1. Should be the same, okay? Why? That are in the series. So that was, for example, that should be the same. I sub D sub 1, I sub D sub 2, I sub R sub 1, okay? Should be the same. Now, the I sub D sub 4 is equal to I sub D sub 3, and then that was the also should be the same as the I sub R sub. Okay, so to find the I sub D sub 4, we keep remaining here. And then we're gonna looking for I sub R sub 1 first, I sub R sub 2. Now, the I sub R sub 1 is what? The Ohm's law, V sub R sub 1 divided the R sub 1. The R sub 1 has already given the 2K ohm, and then V sub R sub 1 is like a 10.6 voltage. So now it was 10.6 divided to 5.3 million. Okay, 5.3 million. Okay, 5.3 million. So what is for I sub R sub 2 here? I sub R sub 2 here. Okay, the I sub R sub 2. Okay, the I sub R sub 2. Okay. So now, so the I sub R sub 2 is, I'm gonna redrawing here. Okay, so right there, this is the R sub 1, this is the R sub 2, this is the diode, D sub 1, D sub 2, this is the germanium, this is the 500 ohm here. Okay, this is the 2 kilo ohm here. Okay, so now we are looking for the I sub R sub 2. It's really simple. The V sub R sub 2 divided R sub 2, that was the I sub R sub 2. The I, okay, in here, the I sub R sub 2 is like 500 ohm here. And then the V sub R sub 2 is, we have already calculated, is what? 0.8 voltage. 0.8 voltage. So 0.8 voltage to divide the 500 ohm here, that was 1.6 million. 1.6 million. So I sub R sub 2, 1.6 million. So now, what is the I sub R sub 3? Here. What is the I sub R sub 3? Same thing. I sub R sub 3, V sub R sub 3 divided the R sub 3. The R sub 3, 1 kilo ohm, and V sub R sub 3, we have already calculated 1.4 voltage. 1.4 voltage, that was 1.4 milliamp. So now, oops, now, here we go, right there. Okay, the I sub R sub 3 is, to calculate it, 1.4 milliamp. So now, I'm going to change the color, more hickey, right there. Here we go. Right. So here, this is the I sub t, right? In the few minutes ago, White may be asking me, Professor, I sub R sub 1 same as the I sub t? Yes. But here, this is the I sub R sub 2. And then this is the I sub R sub 3. And this is the I sub D sub 3. So now, what does that mean? So the I sub t is I sub R sub 2 plus I sub R sub 3 plus I sub D sub 3. So now we know I sub t, we know I sub R sub 2, we know I sub 3. So finally, we can find, sorry, we can find the I sub D sub 3, right? So go back to here. So I sub D sub 3 is I sub t minus I sub R sub 2 minus the I sub R sub 3, okay? In here, the I sub t is same as I sub R sub 1, okay? So that was, we have already the calculated I sub R sub 1 was right there, 5.3 milliamp, 5.3 milliamp minus, and then the I sub R sub 2 here, okay, 1.6 milliamp. And what is the I sub R sub 3? We have already calculated I sub R sub 3, I sub R sub 3, just right there, 1.4 million. 1.4 million. Okay, so 5.3 million minus 3 million. So that was what? 2.3 million. So finally, I sub D3 or I sub D sub 4 is 2.3 million. So go back to the circuit here. That's right there. Okay, so the I sub D sub 3, I sub D sub 4, the same current because they are in the series. Okay. All right. Any questions? Okay. So the circuit. Okay. This is my last question. Very quickly, I'm gonna go over. Okay. Sorry about just a little bit. All right. Right there. The last circuit, the last page, on the page 21. This is the D sub 1 silicon, and that was the D sub 2. This is the D sub 2 silicon as well, and that was the R sub 1 3.3 kilo ohm here. Okay. This is E, the 20 volt. That was, I'm sorry, this is the R sub 2. Okay, this is R sub 2, 5.6 kilo ohm here. Okay, now, what is for V sub R sub 2? What is for V sub R sub 2? E minus what? V sub D sub 1 and what? The 20 volt silicon, right? Minus 0.7, silicon minus 0.7. So that was 18 what? 6, right? Yeah. So that was for V sub R sub 2. And then what is for V sub R sub 1? You don't need to calculate it by using Ohm's law. Here, or pattern. See that? Just like this one. You can draw like this one here, right? This is the pattern. V sub D sub 1 is what? I mean, V sub R sub 1 is V sub D sub 2, right? What is the V sub D sub 2? Silicon. The 0.7, yes. Here we go, right there. Okay? And then the I sub R sub 1 is V sub R sub 1 divided the R sub 1. The R sub 1 is, that was the given, 3.3 kilo ohm. And then V sub R sub 1, we have the calculated 0.7 voltage. So I'm going to just calculate it, 0.7 divided 3.3, okay? 0.2 milliamp. Why? Because the 1 over K means 1 over 1,000 mean 1 milli. Oops, right there. Here we go, 0.2 milliamp, okay? All right, any questions? Okay. So next week, I have a little bit one more time, the circuit in here more in detail. But today,